Welcome back. In this last video for this unit 5.2, we're going to talk about perception. If you remember how we defined sensation and perception in the first video, we said that sensation is mere capture of information by your sense organs. Then perception is interpreting a part of the sense information, interpreting as by the brain. The question is, what do we interpret an object as? Well, we're going to talk about what it is in the next slide. Again, keep in mind, it equally applies to words. So you do fixation here, and before you go to saccade with another fixation, you perceive the printed letters as, that's right, as words. So in the context of reading, perception is basically identifying the printed letters as a word. Now I'm going to show you in the next slide a picture of something, and I want you to identify it as quickly as possible and say out loud what it is. Are you ready? Okay. What is it? That's right. You might have said a puppy or a dog or a beagle. Well, this particular thing that consciously happened when you made a decision about what it is, that is perception. Perception is interpretation of an object as something. In this case, it's a dog. So perception is nothing but object identification, object recognition, or in general terms, you can also call it pattern recognition. You're identifying the pattern as perception, as dog, and that is perception. So one more thing you need to understand here is that this might not be the dog you have experienced ever in your life, correct? Most likely, right? But still, you're able to identify this new dog you ever saw as a dog. And that is because we have concepts or categories based on our experiences. We have concepts of dogs. A dog is an animal with so and so and so and so and so and so features, correct? So when you perceive a new dog, you're identifying this new dog as an instance of a bigger category of things called dogs. So what is perception then? Well, perception is merely identifying something as something, basically identifying an object that you are looking at as an instance of a bigger category of things. And it was quick, right? The moment you saw this picture, you said dog or puppy or a beagle. Perception is really quick, even automatic, but it's not a simple process. It is actually a complex problem solving process of identifying the object or identifying the pattern. So we can define perception as interpreting an object as something, which is a complex problem solving process of pattern recognition. So in the context of the sentence though, right, we said that we go through fixation, 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 fixation. And during fixation, you capture the printed letters, right? And what is perception then? Well, you identify the sounds of these letters and the combinations of these sounds as words. No other processing, just identifying. Now think about it. Is it related to the 5 levels of processing anyway? Phonetic, syntactic, and so on and so forth? You're right, it's related to the phonetic processing, right? Phonetic processing involves sensing the information, then identifying the sensed information as a word. So we define perception as identifying an object as an instance of a bigger category of things, right? Now, how do we perceive? What is the process of this perception then? How do we interpret something as something? Well, there are several theories. We can talk about a few of them here. First one is Gestalt. principles. The second one is template approach. And the third one is feature detection or feature analysis approach. These are the most classic theories of perception. You might already learn a lot about the Gestalt principles in your Intro to Psych class. So here I'm going to quickly talk about some principles of Gestalt. Again, not in detail. You already know these things. You can also look at the book for more details, but this is something you already know from your Intro to Psych classes. Okay, so first we'll talk about Gestalt principles. Also, one thing I want to say is that this theory, the first theory, is good in explaining how we interpret, identify objects that are ambiguous, not clear. Whereas the other two approaches better explain objects that are non-ambiguous, unambiguous, clear. Like in this case, you can identify this as a puppy, right? Here, this identification can better be explained by these two theories. Gestalt principles are more applicable when the objects are ambiguous. And first we'll talk about that, then we'll talk about these two theories, and that's it. We're done with this. So we're talking about Gestalt principles, and the first one is the figure ground principle. So what do you see here? Of course, FedEx, but do you see an arrow mark? You don't see it yet? Well, here it is, right? Now, whether or not you see an arrow mark depends on what you're making as a figure, the foreground, and what you're making as a ground, which is background. So if you make the white as the background, right, then you can't see the arrow mark. But the moment you make white the foreground or the figure and the rest as a background, that's when you see it. So one principle, the main principle, is a figure ground principle. According to this, you perceive an ambiguous structure like this, and which depends on whether what you make it to be the figure and what you make out to be the background. And let's look at another example here. What do you see here? Well, you might have seen this picture several times, right? Um, well, you see either, let's say, a vase or two faces, depending on what you make out to be the foreground or the figure and what you make out to be the background. Now, if you make the background to be white, what do you see? Well, you'd see two faces, you're right. If you make the black as a background, then you see the vase. Good job. So this is the basic principle of Gestalt principles of. Then we have a set of grouping principles. There are a lot of them. Again, I'm just going to talk about a few here. Now, what do you see here? A dog. Is it really a dog? It's not the complete picture of a dog, though. Or some may say fox. I had several students say it's a frog. Sorry, a fox. Um, the idea here is that you assume that things are closed. You group objects and you assume that things are closed. And this is not a closed structure, right? We assume these are closed, then it's a dog or a fox or whatever it is. Then there are other things like proximity. According to this principle, what do you see here? Well, people usually say a square of dots. Well, what the principle here is that you group things based on similarity. All these dots are together, so you think that they all belong to one unit. So you say it's a square of dots. Okay. So another is continuity. For example, if I show you like here, right? I'm gonna have a better picture. Okay, let's see. This is a picture. What do you see here? People usually say one curved line and one straight line. In reality, it could be that, or it could also be four different lines. Two curvy lines and two. So we assume that things are continuous, right? So that's the continuity principle. Again, you've learned a lot about these principles. I'm not gonna spend a lot of time on it, but there are several others. You can read more about it from your intro to book, or there is some detail on this one in your cognitive psych book also. Well, we'll move on to the other two theories. which are specifically applicable when the objects are not ambiguous. These are ambiguous, right? But especially when things are unambiguous and clear. And that's what we'll do in the next part of the video. Okay, so when the objects are clear, um, you can better explain that using the other two theories. One is the template approach, the other one is a feature detection or feature analysis approach. First, we'll talk about the template approach. Now, according to template approach, just like a stencil has a model of alphabets or numbers or whatever it is, right? According to template approach, our mind has models, stored models of all the categorizable objects. You have model for dog, you model for alphabets, you have models for different things. So when you encounter a new object, right, the way you recognize this as belonging to a category of things is by trying to fit this new object with the stored model you have of the class of objects that you think this belongs to. So in other words, you take the whole object and compare it with the stored model you have. If you say, let's say A, this is a new object you are looking at right now. Now, the way you define um, the way you define or identify this is by fitting this particular object within the stored model, the stencil of this object, and that's how you recognize this object as A. Now, the problem with this approach is that it's not economical. Just think about it. You should have templates for different versions of just one object. Think about it. We can write A like this, and we have different versions of writing A. Well, I'm not really good at writing the different versions of A, but the point is that each object can have hundreds of different varieties of shapes. So then you should have hundreds of different stencils, right? And it would take forever to actually compare one object with hundreds of models of this given object, which again takes a lot of time. So, although it is a simple explanation, it gives a simple explanation, it's not economical. Now, in the next slide, we'll talk about the last model, that's the the feature detection approach. So, feature detection model, there are several theories within this model, um, but the basic idea of these models or these theories is that as opposed to the template model where you're comparing the entire object with the stored model of that object, let's say the stencil, right? Here, you don't do that. You only compare or identify individual features. Okay, what does it mean? Well, according to the feature detection model, any object that you experience, right, can be divisible or can be divided into its component features. These are called the primary features. These are the basic features, like a square, a triangle, a circle, an edge, a corner, an angle, things like those basic patterns. So pattern recognition then is recognizing the individual features of these objects. Then once you match these features and identify from your brain, your mind, what these features are, then perception is basically matching what objects that you have in your mind actually has these features. So, so you're not comparing the entire object, you're comparing or just identifying the individual components or individual features, then you put together. by identifying those objects that have these features. So that would be feature detection. One example of this model is the self-rich theory of pandemonium, or the pandemonium model. Now, the word pandemonium here is used to dramatize what might be happening in our mind when we detect an object. I'm going to give a brief description of it. Again, you can look at this one from the textbook. But according to this model, there are three different kinds of demons. In fact, four different kinds of demons. A demon is nothing but a mental process. So you have image demon, you have feature demons, you have cognitive demons, and you have decision demons. So these demons are different processes. Okay. So let's say you're looking at an object B. Okay, letter B. An image demon will capture the image of it. All right. Then in your brain, there are several feature demons. There's a feature for vertical line, there is a feature for horizontal line, there is a feature for zero, there's a feature for a parenthesis or thing like this, and one for acute line, one for the semicircle, and so on and so forth. So when the image demon captures this letter B, right, the feature demons, they shout. The demons that have any of the features listed within this will shout. For example, the vertical demon will shout because there is a vertical feature in it. Then two of these will also shout because there are two semicircles. Right? The next layer of demons or processes is the cognitive demons, which are basically the actual representations of the objects you have: B, D, P, M, all the alphabets you have. Now, all the alphabets, right? All these cognitive demons that have at least two features combined within them, they'll shout. For example, B will shout because it has all the features in here. There's a vertical line. What are the ones that are shouting here? Vertical line and semicircles, right? So B has this, it will shout. D also has it, is one vertical line and one semicircle. It will also shout. P will also shout because there's one vertical line and one. But the one that shouts the loudest, cognitive demon, is the B because it has all the features. Then the decision demon or the process will listen to these particular sounds and pick the decision and pick that sound that's loudest. In this case, it is the B. So the decision demon means a decision. Again, it is just an analogy to give you an idea. That's why it's called the pandemonium model. And there are no real demons in your head. Well, this brings us to the end of this last video in this unit on perception. In the first two videos, we talked about sensation. In this video, we talked about perception. I hope you liked it. Stay tuned. Have fun learning.